All right, let's talk about Docker. And look, I get it, it can seem kind of complicated at first, but today we're going to demystify the whole thing. Seriously, forget the complexity. I want you to think of Docker as a developer's superpower. It's a total game changer that lets you package up your application and run it absolutely anywhere, with perfect consistency every single time. So let's break it down.
So here's the game plan for our journey today. We're going to start with the absolute foundation, the blueprint, which is your Dockerfile. Then we'll see how to assemble that blueprint into something called an image. After that, the fun part, we'll launch it as a running container and learn how to actually manage it. Then I'll show you the real magic, live reloading. And finally, we'll learn how to conduct a whole orchestra of services using Docker Compose. Ready? Let's do it.
Okay, first things first. Everything, and I mean everything, in Docker begins with a Dockerfile. The best way to think about it, it's a recipe. It's just a simple text file, but inside, you write down all the ingredients and instructions needed to create the perfect, standardized environment for your app to live in. And this recipe is just a list of super simple, step-by-step instructions. You start with from, which is like choosing your base ingredient, say a specific version of Python. Then workdoor creates a little folder inside the container just for our app. Copy does exactly what it sounds like. It copies our code from our machine into that folder. Run is for executing commands, like pip install to get all our packages. And finally, CMD tells the container, hey, when you start up, this is the command I want you to run. See, each step just builds right on top of the last one. Now, before we move on, I have to show you a quick pro tip, layer caching. So Docker builds images in layers, kind of like a cake. On the left, we have the inefficient way. We just copy everything all at once. The problem? If you change even one tiny little line of code, Docker has to reinstall all of your dependencies. Every single time. It's so slow. But the optimized way on the right is much smarter. First, we copy just the dependency file, then we run the install, and then we copy the rest of our code. Why? Because now, Docker will only rerun that slow installation step if the pyproject.toml file actually changes. This one little trick will make your build so much faster.
All right, so our recipe, our Docker file is written. Now it's time for the assembly. This is where we bake that recipe into something called an image. Think of the image as the final packaged up cake. It's a consistent, shareable, and this is important, unchangeable snapshot that has everything our application needs to run.
And how do we do that? With the docker build command. Now this might look a little intimidating, but it's really not. The T part is for tag. It just gives our image a friendly, memorable name like my app dev. The F flag just lets us specify exactly which Docker file we want to use. And that little dot at the end, super crucial. That tells Docker, hey, all the files you need are right here in this current directory.
And now for the moment of truth. This is the part we've all been waiting for. We've written our recipe, we've baked the image, and now it's time to actually launch it. We're about to run a container and bring our application to life. The command for this is docker run, and there are a few key flags you'll use all the time. Using -d runs it in detached mode, which basically means it runs in the background so you get your terminal back. The -name flag is great for giving your container an actual name so it's easy to find later. And -p, well, -p is for port mapping, and it is absolutely essential for actually seeing our app.
Which brings us to a problem that trips up pretty much everyone when they're starting out. You run your container, you check the logs, everything looks perfect, but then you open your web browser, go to localhost, and nothing. It's blank. Why? Well, it's because by default, a Docker container is a totally isolated little box, completely cut off from your machine.
And the solution is port mapping. That little P flag is how we build a bridge from our machine into that isolated container. So when you type -p 8080/8000, what you're really saying is, hey, Docker, connect port 8080 on my computer, the host, directly to port 8000 inside the container. And just like that, the connection is open and you can finally access your app.
So if you remember just one thing from this whole section, let it be this simple rule. When you're mapping ports, the number on the left side of the colon is always your machine. The number on the right side is always what's inside the container. Getting that right will save you so many headaches, trust me.
Okay, great. Our container is up and running. But now what? How do we manage it? How do we see what's going on, or stop it, or get rid of it? It's time to check out our control panel and learn the basic commands for managing the container lifecycle.
Here's your essential toolkit, the commands you're going to use every single day. Docker PS shows you what's currently running. If you add -a, you'll see all of them, even the ones that are stopped. Docker stop and Docker start are basically your on and off switches. Docker Logs is your absolute best friend for debugging. It shows you all the output from inside the container. And when you're done, Docker RM is how you clean up and remove a container you don't need anymore.
All right, now for the real magic trick. We've got the basics down, but now we're going to unlock a feature that will literally supercharge your entire development workflow. This is a big one.
So, you're in the zone. You're coding away. You change some text, you hit save, and then you go check your running application and nothing's changed. What's going on? Well, remember what we said about the image being an unchangeable snapshot? The code inside that running container is frozen in time, from when you built it. It has no idea you just changed the files on your computer.
The solution to this problem is a beautiful thing called volume mounting. It's an incredible technique that basically creates a live two-way sync, like a magic portal between a folder on your machine and a folder inside the container. This lets us completely bypass the static code that was baked into the image and instead points the container directly at your live, working code.
So here's the new workflow. First, you'll stop that old container. Then you rerun it, but this time you add the v flag for volume. v./app tells Docker to sync your current directory, that's the dot, with the app folder inside the container. And just like that, any change you save locally is instantly, and I mean instantly, reflected inside the running container. This creates that immediate feedback loop that is the absolute key to fast, happy, productive development. No more rebuilding for every little change.
We've totally mastered running a single application in a container. That's awesome. But let's be honest, modern apps are rarely that simple. It's time to level up, to go from playing a single instrument to conducting a full-blown orchestra of different services.
I mean, just think about it for a second. A real-world application probably has a back-end API, which needs to talk to a database, and you might also have a web front-end that needs to talk to that API. Trying to manage all of those with separate, complicated Docker run commands, it would be a complete nightmare.
And that's exactly where Docker Compose comes in. It is the conductor for our orchestra. It's this amazing tool that lets you define and manage all of your app's different services together in one single, surprisingly simple and easy-to-read file.
I mean, just look at the difference here. The hard way, on the left, involves you trying to remember and type out multiple super long complex commands. Getting all the flags right, it's just asking for trouble. The easy way? Once you have your Docker Compose file set up, you just type one thing, Docker Compose up, and boom, your entire application stack, the database, the API, the front end, it all just springs to life, all connected and configured perfectly. It's incredible.
So there you have it. We've gone from a simple text file recipe all the way to conducting a multi-service orchestra. You now have the fundamental superpower of Docker, the ability to package up literally any application and run it consistently on any machine in the world. The only question left is, what amazing thing are you going to build first?